All right, guys, today we're going to be looking at key features of quadratics, which we're going to also be looking at the interpretation of each key feature. So we're going to be identifying them, and we will talk about what they mean in terms of the situation. So let's get started. A roller coaster at Asheville goes into an underground tunnel during the first descent of the ride. The coaster enters the tunnel 3 seconds after the first descent, starts and stays in the tunnel for a total of 2 seconds. The roller coaster is 40 feet above the ground 1 second after the initial drop. Use the graph below to complete the table. Okay, so when we're doing this, I want you to be thinking about what did we just read in this problem, okay? Anytime you get a word problem, you want to think about what did we actually just read. So we're at Asteroid. I don't know if you guys know about Asteroid, but it was this super fun place back in the day. Some of your parents probably know about it, but it used to go down at Asteroid. So we're at Asteroid and we're going to be on a roller coaster, okay? So we're here. And y'all know me, I like to draw, and we're on a roller coaster. Maybe this is you and your friend or you and your family. You're on this roller coaster, okay? So it says we're going to be entering a tunnel 3 seconds after the first descent. That means that it's going down, and it's going to stay in this tunnel for 2 seconds. And I also know that at 40 feet, or it's going to be 40 feet above the ground at 1 second. So I can go ahead and even write that as a coordinate point. Okay. So the first thing I want to do before I really get into this, let's go ahead and label this. So we know this axis here is our x-axis, and it's going to be in terms of time. So I want to think about what I'm going by. And what I notice is I have this 3 here and I have 6 spaces in between, which means it's going to be going by 0.5. So I'm going to just label every other one. So this is going to be 1, 2, we have 3, we have 4, 5, 6, 7. All right. Then my y-axis, okay, I see we have 40. Okay, and we have 8 spaces in between. So that's going to be going by 5. So I'm going to number those as well. Okay. So before we get into the meaning, let's go ahead and do the easy part. Let's identify our key features. So we know our y-intercept is where it crosses the y-axis. Okay, so we see here, we're starting at 0.75. So that's going to be our y-intercept. Okay. Then next, we want our X-intercept. Keep in mind, those are also our root zeros in solution, so they can interchange those words. And I have 2 of them. Okay, so my first one is 30, and my second one is 50. So we're just identifying, okay? Our vertex, remember that's either our highest or our lowest point of the graph. This one we have a minimum point, and that's at 4, and it looks like our graph is going to go down to the 4th quadrant at -5. So my vertex is 4, -5. Since this is at the bottom, it's going to be a minimum value. And remember, our minimum value is our y value of our vertex, so it's going to be -5. Okay. Our axis of symmetry. Okay, remember our axis of symmetry goes straight through our vertex, and it has to be x equals because it's a vertical line. So that's going to be x equals 4. Okay, now here's where it gets a little tricky, because we know when we're dealing with domain for quadratics, most of the time it's all real numbers. Here's one of those cases where it's not, because we're talking about a roller coaster and we're talking about time. Okay, if we were to say that this is all real numbers, that would mean that we travel back in time and we're riding a roller coaster. And if we say it was going to continue to positive infinity, that means we're going to be on this roller coaster forever and ever and ever. And no one wants to ride a roller coaster, no matter how fun it is. Nobody wants to ride a roller coaster till infinity. If you do, then hey, go for it. But this one is going to have boundaries. So I'm starting at 0 and I'm ending at 7. So my domain is going to be 0 to 7. This is continuous because this ride is going to continue from 0 to 7. So I'm going to have my inequality notation like so. All right. Keep in mind, this is red. My x values are greater than or equal to 7 and less than or equal to, sorry, I said that wrong. X values are greater than or equal to 0 and less than or equal to 7. All right. Then my range, remember, I want to go from the bottom to the top. So we have this starting at -5 and we're going to 75. Okay, so my range will be -5 to 75, and then I have my inequality signs in the middle. In most cases, when I'm dealing with a real world scenario, I'm going to have the equal to on my inequality signs. Okay, so that's my y values are greater than or equal to -5 and less than or equal to 75. So now the fun part, we want to talk about what this means in terms of the problem, and we do want to use complete sentences. So we have our x, which is our time. Our time is in seconds. And our y is our height. Our height is in feet. Okay, so anytime I'm talking about x, I'm going to be referring to that time of the roller coaster. And anytime I say 75 or I say my height, I'm going to be referring to the feet or where the roller coaster is in the air. Okay. So if my y-intercept is 0, 75, this will mean at 0 seconds, I am 75 feet in the air. Okay. So we know that a y-intercept is always a starting value. So we're just going to say that right here is where we started. Okay. We're on the ride. We're getting in the ride. We're putting our seatbelts on. The person there is checking in to see if we're all, we're all safe before we get on a ride because we don't want to fall off or anything like that. So that's all what's happening here at our y-intercept. So I'm just going to say the ride started 75 feet in the air. Okay. My next one is my X-intercept. So I have something happening at 3 and 5, okay? We read in the problem that it's gonna go in a tunnel for 2 seconds. So from 3 to 5, that's actually 2 seconds. So from my first X-intercept to my last X-intercept, that's gonna be when that ride is in the tunnel. At that point in particular, that's when it's entering and it's exiting. So I'm going to put the ride enters the tunnel at 3 seconds and exits at 5 seconds. All right. Now we know our vertex, again, that represents the highest or lowest point. This is actually our lowest point, and it's 4, -5. So I'm going to say at 4 seconds, the ride is 5 feet underground. Okay, a lot of people asked me earlier, well, Miss Hasu, why wouldn't you put -5? We don't say we're gonna go negative downstairs, or we don't speak like that. So we don't need to say that when we have the problem. We're already saying we're going underground, so that already implicates the negative. So at 4 seconds, the ride is 5 feet underground. Here, I just want to talk about my Y for my minimum value. So I'm going to put the ride reaches its lowest point at 5 feet underground. All right. Our axis of symmetry won't necessarily have a real world meaning. In mathematical terms, it just means the middle of the graph where it splits through the vertex. So we don't have to worry about a meaning for that one. Now our domain, remember, we're talking about X and we're talking about time. Okay. So the time of this ride, I'm thinking about the total time. Okay. So it was from 0 to 2. Okay, and we're talking about seconds, so that's 0 to 2 seconds. So I'm just going to say the ride lasted a total of 2 seconds. When somebody said that's a short ride, I mean, I get it. Maybe, sorry, not 2 seconds, 7. Okay, I was thinking about those 2 seconds in a tunnel. So this ride is 7 seconds. Somebody did say that this ride was really short. Maybe so. Maybe it's one of those roller coasters that go back and forth, or maybe it's a kiddie roller coaster. So yeah, the ride lasted a total of 7 seconds. And then for my range, I'm thinking about my height. So my height starts underground. So I got to keep in mind that that's that 5 feet. And it goes all the way to 75 feet. So if you think about it, that's a total of 80 feet. Okay. So the ride is 80 feet high. And that's it.